Welcome everyone. Here we are going to discuss something really nice and simple. You have a picture as shown, that's like our two 5x5 unit squares arranged one beside the other, and they are connected with two unit cells, two pair of unit cells that sort of acts like a bridge between those two squares. Can this picture shown, which is divided into unit cells, be covered with dominoes? What are dominoes? It is a 1x2 grid in this structure that has this structure. So this is called as a domino. Now using this, can you pave this entire structure? So paving or covering just means you have to lay them without any overlap and without any protrusion out of the given picture. Think about this. We will solve this using coloring methods, what is known as coloring methods. Coloring methods is a proof technique that lets you establish some pattern of a particular configuration, some property of a particular configuration. Let's get started. Alright, suppose let's label the unit cells on the bridge to be AB and CD. Notice that a domino has even number of unit cells. It has two unit cells. 2 is an even number. Now, if you consider the covering of A and B, either it can be in this way or for A it can be in this way. There are only two possible ways to cover the unit cell A. Same goes for C. Either you can cover C in this way or this way. The domino that covers C has only two possibilities. Same goes for A. Since dominoes act as a building block of this cover, it can only cover even number of blocks, as each building block is made of even number of cells. So even plus even plus even will be always even. Whereas this entire structure, the left 5x5 square, has 25 unit cells, which is an odd number. So we have to use something else. We cannot cover this entire thing, which means I have to remove either this cell, which can be done by covering it with A, or I have to remove this cell. There is no other possibility you are going to get even number in the remaining. But I should not remove both. So for example, without loss of generality, let's say I remove this unit cell by covering it with A. So remaining you have 25 minus 1, which is 24. This is an even number, and we can try attempting to cover all these 24 unit cells. By the way, you should not have the cover of C coming into the left 5x5, because otherwise the total number of remaining cells will become odd, which we cannot pave. So the structure that remains is a 5x5 with 5 columns and 5 rows, with the square in the last column and the second row being removed. This gives us total of 24 unit cells. Can you cover it with a domino? You may start thinking about this as we work upon this problem. Here is where we will incorporate coloring method. Once again, this is a proof technique that enables us to bring out patterns or highlight the patterns that are present in a particular configuration, or some properties of this configuration can be highlighted using this coloring method. Well, how to color exactly? For example, I'm going to use two colors and color this structure like a chessboard pattern. Like 1, 2 means 1 for black and 2 for white. So 1 is for black color, 2 is for white color. So now you can understand that this is just like a chessboard coloring pattern. So you have 1, 2, 1, 2. You do not have 1 and 1 in two adjacent cells that share a common edge. So you have 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1. So I'm just removing this because it's never possible to color along with this, as there should be even number of squares. But notice in this coloring pattern, wherever you place your domino, it is going to contain one black and one white. A domino is going to cover one black and one white, or you could say 1 and 2. There is no other way you are going to cover this with domino that has 1 and 1 or 2 and 2 by the nature of our coloring. We followed chessboard pattern. There are various ways to bring out or highlight the properties of a configuration. This is just one way. Why am I doing this way will be obvious soon, but as you solve a lot of problems using coloring methods, you will learn this intuitively by yourself. Consider the number of ones here: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So there are 13 ones. How many twos? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 twos. Now tell me, how are you going to cover the entire structure with dominoes that has equal number of ones and twos in each of its building block? Which means in total, you are going to have the same number of ones and twos if you are able to cover. But it turns out the number of ones and twos we have are imbalancing each other already. So if you are able to cover it with domino somehow, then you arrive at a contradiction because of this fact. This is what I exactly mean by bringing out or highlighting the property of that configuration we are working with. Hence, it is never possible to cover this configuration with dominoes, which can be highlighted through coloring in chessboard pattern. So now I think you will have some intuition on why we did this instead of doing something else. But there are other patterns like 1, 1, 2, 2, things like that. So they work in some other configuration or circumstance. You can also tell your own ideas. So the answer is no, because you cannot cover the part of it. So the left part cannot be covered. Same goes for the right part. So they are symmetrical. If you have your own ideas, you can comment it in the chat box. In SuMON math program, we solve and provide students with a lot of these kind of problems that intrigue and make the students think creatively and meditate over the problem for a longer time rather than studying the rote system of problems and its solution. So we want students to attempt on their own and spend a lot of time, which cultivates the habit of doing research from their childhood. We believe that research slowly gets cultivated in the mind of students rather than the students plunging into that in their adulthood. So if you are interested, you can start with our SuMON process by subscribing to our free trial worksheet at www.sumonmath.com. Thank you everyone for watching. Meet you in the next video. Bye.